Welcome to Unit 3, Section 3, Proving Lines Parallel. We are going to continue looking at our corresponding angles, alternate interior angles, but this time we're actually going to show the lines are parallel instead of showing the angles are congruent. So before I go into the notes, I want you to just look at the title of this first theorem. It's called the converse of the corresponding angles postulate. And you might recall the word converse. Remember when we studied logic and reasoning, you began with conditionals, if P then Q, and we talked about the converse was if Q then P. So it switched the hypothesis and conclusion. So what I want to show you is that these new theorems and postulates today are simply the converses of the four we just studied. So I went back to our notes from the other day, and remember we took notes over corresponding angles postulate, alternate interior, alternate exterior, and same side interior. And so I went ahead and grabbed the first postulate. Now you don't have to write this down, I just want you to listen because this will help you understand more where these come from. So I rewrote the corresponding angles postulate and I abbreviated a little bit. The corresponding angles postulate from our notes basically says if two parallel lines are cut by a transversal, then the corresponding angles are congruent. That's what we've been studying. So that is my conditional, if P then Q. So I'm going to write the converse. And if I did that, I'm thinking if Q then P. So I can switch the hypothesis and conclusion. So remember, the conclusion goes with the word if. So if corresponding angles are congruent, if corresponding angles are congruent, then, and I'm going to rewrite the hypothesis, two lines are parallel. Let me abbreviate that by basically saying then two lines are parallel. Then two lines are parallel. So my converse says if you have corresponding angles that are congruent, then you have two parallel lines. And the reason I wanted you to listen to that was I want you to look at what our first postulate is. Our first postulate says, if two coplanar lines are cut by a transversal so that the pair of corresponding angles are congruent, then the two lines are parallel. So the hypothesis is if corresponding angles are congruent, corresponding angles are congruent. So here it is. If corresponding angles are congruent, then the lines are parallel. So that's my converse that I generated from simply writing the converse of the postulate. So what I want you to think about through this is we are simply switching the process around. I am now going to tell you, hey, you have these congruent corresponding angles. You're trying to show lines are parallel. And so now we have a converse for every single theorem we had the other day. So my first converse says, notice if you are given the congruent angles, this is given, notice it's marked on your picture. If you're given that corresponding angles are congruent, then you can say, well, the lines have to be parallel. There's no way these angles can be the same measure and these two lines not be fixed at a certain angle to be parallel. Okay, so we're just going to do a little bit of checking, not a whole lot of calculating today. So number one here, we want to use the converse of the corresponding angles postulate and the given info to show that L is parallel to M. Now notice on your picture, you're not told you have parallel lines. You're trying to prove that. So here's what you're given. You're given that 4 is congruent to 8, so let's mark that. Angle 4, put an arc on, and angle 8, put an arc on. So when you do that, you should look at that picture and say, those are corresponding angles. So I'm going to maybe jot down that angle 4 and angle 8 are corresponding angles. And once I recognize it, then I can say, well, this converse, let's scoot down, this converse says if corresponding angles are congruent, then the lines are parallel. So I would say that L is parallel to M, and all I did was demonstrate the converse of the corresponding angles postulate. So I'm going to abbreviate it like this. The converse, and I'm not going to abbreviate that word yet because I want you to get used to that word. The converse of the corresponding angles postulate. And that's all we're doing here. We're just trying to show, I'm just trying to show you what that would look like. Okay, next example. We want to, again, use the converse of corresponding angles postulate and the given information to show L is parallel to M. So I'm given information on 3, so let's put a little star right there. I'm given that information, and I'm given information on 7. So those two are corresponding angles. If I can show them to be equal, then I have parallel lines. So I'm given a value of x, so let's plug that in and see. So the measure of angle 3 would be 4 times my x times 30 minus 80. And so if you calculate that, if I did 4 times 30 minus 80, I get 40 degrees. Okay, so I got 40 degrees here. So the measure of angle 7 is equal to 3 times 30 minus 50. Okay, so let's calculate 3 times 30 minus 50, and I get 40 degrees. So I get 40. So I look at that and say, well, since my corresponding angles are congruent, my lines are parallel. So I can finish off the same way I finished off above. L is parallel to M by the converse of the corresponding angles postulate. So you're really verifying information right now. Okay, I would like for you to go ahead and let's do 1A as secret question number 1. Okay, and then I'd like you to do 1B on the next page as secret question number 2. Okay, so if you need to pause the video, you can finish those out. Okay, what I'd like to look at, I'd like to skip this parallel postulate. We'll look at that another day. But basically what I want to show you on the next 3 pieces here, we've got, and let me get a highlighter here. I have the converse of the alternate interior angles theorem. I have the converse of the alternate exterior angles theorem. And then I have the converse of the same side interior angles theorem. So notice I have the 3 converses for the same theorems I had before. So they all very much say the same thing. So the converse of the alternate interior angles theorem says, and I'm going to underline the important parts, if alternate interior angles are congruent, then the lines are parallel. So if you're given incongruent alternate interior lines, then you can say the lines are parallel. Next one, if alternate exterior angles are congruent, then lines are parallel. So all you have to do is look for those angles. Now on the third one down, if same side interior angles are supplementary, remember this is the one that's not congruent, then the lines are parallel. So notice every single time we are concluding parallel lines. You are not given that information. So let's go on to another example. Use the given information in the theorems you have learned to show that R is parallel to S. So I'm going to write the converse right here because that is what you're trying to use. So we're told 4 is congruent to 8. So mark this on your picture. So 4, put an arc, and 8, put an arc. So when I look at those, I say to myself, those are alternate exterior angles. So these are alternate exterior angles. And so I have a converse that says, if your alternate exterior angles are equal, then your lines are parallel. So I can say here that R is parallel to S, and the reason is the converse of the alternate exterior angles theorem. Converse of alternate exterior angles theorem. I think I pointed you at the wrong converse. We should be looking at the alternate exterior, not interior. So identify what the angles are, and it's the converse of the name of the angles. So this is my answer right here. That's my solution. Number 2, use the information to show R is parallel to S. So we have 2 and 3. So put a star on 2 and put a star on 3. So when I look at those are same side interior. And if those same side interior angles add to 180, then my lines are parallel. So let's plug in 5 and see what we get. So the measure of angle 2 is equal to 10 times 5 plus 8. So 10 times 5 plus 8, I get 58 degrees. And then the measure of angle 3, I get 25 times 5 minus 3. So 25 times 5 is 75 minus 3. No, not 25 times 3. 25 times 5 minus 3 is 122 degrees. So remember, I'm trying to see, are these supplementary? So let's add them up, see what we get. So 122 plus 58, I do get 180 degrees. So I can say R is parallel to S by the converse of same side interior angles theorem. So showing my work here and listing out the converse, I have proven that they're supplementary. So I would like for you to make, you try number 2A, secret question number 3, and I'd like you to do the same thing here, secret question number 4 for you try 2B. Okay. I think what I'd like to do, let's skip the last 2 proofs. We will do those together in class someday. So why don't you finish up? You've got 4 secret questions. So if you would finish that up and submit the WISP, we will spend some time on this in class.